Hello, Boone. Hello. Welcome.
Hello.
Yeah, I can hear you. So, yeah, check the email. It's like today's agenda.
Okay.
So since other people hasn't come yet, maybe we start from the link. Actually, I shared with you the link before, but I made much improvements to the text in the link. Hello, Tor. Hello, Tor. Can you hear me?
I can hear you.
Yeah. Maybe he's struggling with his device.
How did Zoom become so successful? Every time I connect, I have to figure out how to connect my audio.
Well, I'm curious too. I'm curious why Zoom becomes successful.
Oh, Paul says that he can't hear us.
Yes, but remember 2 hours ago when I joined the meeting in our company, I quit and joined again for the same reason that everybody's speaking, but I cannot hear them.
Hmm.
Well, originally intended to present the DAR parser that I implemented as a AWS Lambda. But that is not important now because if we're not using attestation in our project, the implementation is not important, only the design is. So we may as well skip that.
Okay.
So we talk about design stuff. When we
Okay.
come to the point of implementation, I will talk about implementation, like which tool works to which extent. So the design is mostly URL schema and smart contract interface. I didn't get around to prepare the smart contract interface, so there's only one thing to look at, which is your URL schema.
And I keep getting these notifications that the host is changing.
Mm. Hello, Tor.
Hey, sorry about that. Apparently, my computer decided to speak as some decided to be on holiday. I had to reboot the whole thing. I got like when I opened it today, there was no sound at all. Not just
Oh,
here, but
yeah. Sometimes I will dial in because I'm on the move and the mobile phone is performing weirdly. So
oh, okay.
here's a link of a mobile phone number to dial in just in case.
All right, yeah.
Mm.
Yeah, I don't know. It's the first time my computer has decided not to have its speakers working. That's why it also took a bit of a time to figure out because I was sure it was a configuration issue. So I found out it wasn't.
Yeah. So Tor, remember a while ago, like in December, I mentioned. So we set out to do different things. I asked you to produce a DER-based parser based on my schema, and ASM.1 module, and I set out to do the same, but on Java instead. And I have done my part, and you have done your part, I think. You sent me the smart contract code, which I didn't test, and I have written a Java-based ASM.1 parser, implemented one, not written one, and then I deployed it on AWS as a Lambda. So that idea is the applications can call the Lambda by sending the DER, and then it returns the JSON interpretation. This is so that Android and iOS can use it at the same time without writing implementation separately as a middle stage. And then that work is done. I will check your work as well, but there is a shift in priority that we in the company, we decide to focus on event support instead of attestation. So that's why I didn't continue from that piece of work.
All right.
Okay, so thank you for delivering it in time, and sorry for not using it because the project direction changes slightly. We're working on event support in the next few weeks. Now, because we are not implementing attestation in this month, I think today we will simply talk about design and not the implementation. I originally wanted to present the AWS implementation and talk with you about the smart contract implementation. But thanks to the change in priority, let's discard that and just look at design. So the piece of design I want you to have a look at today is the one I mentioned in the email. I also posted a message here in the chat room. And if you have seen this before, then that's the draft. This one is more elaborate.
All right.
Okay, so basically, this is about how to deliver attestation by URL. So I'll give you one scenario that suppose you have a CryptoKitty and you want to sell it for 3 ethers. What you can do is to generate a link, which is a signed message, which is attestation, says that you are willing to sell your kitty for 3 ethers. And that is a signed attestation that you can send to a friend. Your friend who wants to buy it with 3 ethers can click that link, and the TokenScript will help your friend to generate a transaction that uses that attestation together with your 3 Ether to change the ownership. Make sense?
Yeah.
That's one example of attestation. It basically it can be anything. Basically, attestation is needed parameter for next transaction, or itself can be delivered through link to some other people. For example, if I request you, if you are authority and I'm a user, I will request a attestation of my ownership of email address to you, and you might deliver that attestation in the form of a link. Then I simply import it. That's the other use of turning a URL format of the attestation.
Okay, all right.
Yeah, so even if you just provide me with a link and I import it to my wallet, this link can be transported through email and other stuff. And it's not a big secure concern because it doesn't have the private key. It only attests to the public key.
Yeah, all right.
Okay, so this is why we have a URL schema for attestations. So now let's look at this message, and I will walk you through this. And Boone, are you following?
Yes.
Okay, so I first presented a very basic attestation, which is attestation column, followed by the smart contract, which the attestation is relevant of, followed by the attestation itself, which is DER, then encoded in base 64, which is AER, right?
Where is that on the page?
That is the first block of quoted formatted text. You know,
okay.
that the six lines of junk. The 6 lines of junk are made of attestation column, which is the protocol header, followed by the smart contract address, followed by a long base 64 string, which is CER encoding of the attestation. So that's all right.
Got it.
Then if we go down from here, this is apparently too long. So the rest of the text is about how to shorten it. So to shorten it, let's look at what is inside attestation. Look at the JSON representation, okay? Sorry, I spelled it as JASON, but you know what I mean. It's JSON. It should be JSON. Just search for the word JASON.
Yes.
Found it? Okay, so this is what is inside attestation before it was encoded or encoded in JSON format. So it has like a header stuff, public key stuff, data object, and signature algorithm and signature value, right?
Right.
Okay, and data object is the part that is being signed. Other stuff are just header and tail. So in this case, it's a attestation of a TIFA ticket or UEFA ticket, which has 3 fields: match, class, and admission. Basically attests to the key holder's right to enter this match. Okay, so the direction I'm going is most of the content, the header and the tail and the footer of this long attestation can be determined either from the schema or can have a default value. For example, we can simply say that the signature algorithm defaults to ECDSA CP256K1, for example, or we can set a default value in the schema of this attestation. So only these parts cannot be only the data object and signature value cannot be obtained from the schema or guessed out from default value, right?
Okay.
Make sense so far? So the idea is, why don't we simply present the value that we cannot guess, then with TokenScript in hand, even if you have the TokenScript, which include the attestation schema, we only include the data that cannot be implied from the TokenScript. We only include such data in the URL. So we get something similar to have a look at the next encoding block. Actually, look at the one that says SECP 256Q1. Found it? That's a three line long. That's a attestation link 3 lines long.
Yes.
Okay, so what's in it is first attestation, protocol header, followed by 0x, that's the smart contract that is relevant, followed by match ID, match equals to 1, class equals to launch, admission equals to 1. That's a ticket. That's the data object. And then followed by the signature, which is almost 2 lines long, right?
Right.
So this is possible because the data type of match 1, for example, is an integer, and the class equals to launch. Launch is a, let's say, unit string. So the type of this is embedded in schema. So you can reconstruct this attestation in memory, and then check that signature against this in-memory attestation. So the attestation is not on the UI in memory, and then signature is validated against that. So far so good.
Yes.
Hello. Yeah, so far
Yes.
so good. Okay. Now the next thing is next thing is 64, which makes it shorter, and then there is a mobile-friendly version, which is rapid inside it. First, this is design. This is design I have, and maybe you guys can start commenting, and then I will go through the next solve. What do you think?
The last block, when you say for it to be web or mobile friendly, what do you mean?
Oh, so because when it's on the web, some web JavaScript will mistakenly think that the plus symbol in base 64 is special meaning, but actually just part of the URL. I don't want to break any URL recognition JavaScript or web stuff. So I want to use safe character set for base 64. And for mobile friendly, I mean that mobile phone does flexibility of new protocol headers. You cannot define new stuff like attestation. Am I right? So you have to wrap it inside.
Oh, you mean you wrap it like a link and then the user can tap on it, or just for processing?
Yeah, so that you have it and it will launch our wallet, for example. So I was under the impression that then you cannot configure mobile phone to open it with Alpha Wallet.
Give me a minute, I'll be back. You're breaking up.
Okay.
It might also, I mean, like in the last minute or so, your connection has been a bit unstable. I think it might be on your end, since both Boone and me experience it.
It happened right after my daughter come home, so maybe she's watching TV. Let me do something about it. Yeah. Okay. So yeah. So is it better now?
It's fine now. It's fine now. Yeah.
I hope. Yeah, okay. Yeah, should be working now. So I switched connection. So Paul, what did you say?
What was your last question about mobile something? I missed that.
Oh yeah. So by saying mobile friendly, I was under the impression that you cannot make a mobile phone open a link starting with attestation double colon. Mobile phone can only open link through HTTP colon something.
You sort of can do it, but the problem is, at least on iOS, any app can mark themselves as a handler for such links. For example, attestation colon.
Which might be okay because the user might have a competitor product than Alpha Wallet, right?
Yes, but the problem is if Alpha Wallet and some other wallet both mark themselves as an app that supports this, which app gets launched when the link taps is unpredictable.
And is there any app that simply register all possible URLs just for the fun of it?
Possibly, I don't know.
Yeah,
but there is a limit now.
In China, WeChat registered itself as the opener of all the possible protocol you can imagine.
Okay, but that doesn't help because the which app gets launched is not predictable.
Okay.
And if you wrap it with a HTTP or HTTPS URL scheme, the problem is, in your example, you're using attestation.id. That means the owner of attestation.id,
which is me.
Yes, will have to specify which are the apps which can act as handler for this, which means that if there is a third-party application app which wants to handle this, they have to go through you.
Yeah.
You have to give permission.
Okay, so I'm giving you this. Wait a moment. I'm working on this, modifying this to reflect what you said. Okay, so updating document, save, edit. Yeah, check this change. Oh, wait a moment, I broke something. The format is completely broken. Yeah, now I just saved it. Wait a moment. Okay, can you see the new version? I simply noted that this version can guarantee to be opened by a specific app.
Okay, yes, I see it.
Okay. So, so far, what do you think about this URL schema? And I will then present the problems.
Looks good to me.
Okay, so problem number one is in this version, I have left out public key because it can be recovered from the signature, and it is usually done in Ethereum. I mentioned before that in Ethereum transaction, usually you put a signature there and you don't put public key. Instead, the client whoever receives it was supposed to reconstruct the public key from it. But it's possible to reconstruct more than one possible public keys from the signature RS value. And somehow the third value is used as V, which is a selector, which indicate which of the possible public keys reconstructed is going to be used as the real public key. Now, there's a problem of how to encode V. If we leave out public key in the URL.
Okay.
So basically, I don't have a solution for that. One solution is simply insert it into the signature, but that makes the signature incompatible with RFC, which means when you produce an in-memory representation of the attestation, it's not going to reuse the same thing that is in the link as a signature. We would use a modified version of it, which is confusing and I don't know, maybe not so good. And the other idea is to use the separators. So you know that at the end of the object class, there is a semicolon and then followed by the signature, right? So that semicolon can change to different characters, depends on which public key is intended.
Okay. That sounds like an odd choice.
Sounds like what?
Strange choice.
Yeah, I don't know how to solve this problem though. Like I just propose some bad ideas to start with.
Can't you just encode it like just add it in with semicolon and then 1? A V equals 1?
Yes, but that begets the question, why don't you encode R and S as a R equals to S equals to? And the current way that is encoded into a sequence, you can see by RFC 5480, the current way it is encoded in sequence is the same format that you would see in X509, for example, traditional attestations. So if we change it into R equal to S equal to V, there's a translation going on, which is not bad either. So yeah, that's what, because every other solution is also not good. So maybe we simply encode R equal to something, S equal to something, V equal to something. So I just add that as a third option. Yeah. What do you think, Tor?
It's a good question. I don't have any good idea for it right now. I don't have any strong opinion in which way it would be able to encode this.
Tor, I have what is the range of R and S value in the ECDSA signature? Are they always going to be positive?
I mean, it's basically, it's all over, working all over a group, or I mean, an elliptic curve group. So
oh yeah, so it's always positive.
So it's always positive. I mean, you can also view it as negative, but it also has a positive representation.
Yeah. So, So when you generate R and S, you have two possible pairs, right? I read somewhere that in elliptic curve signature, you can generate two possible R and S values. Depends on if you prefer to use a negative or positive value in certain steps of calculation.
Come again?
So
you said it's different options.
So I read somewhere that in elliptic curve signature, for one message, for one value k, which is random value, and for one private key, you can actually generate two RS value pairs. Both are valid signatures.
Okay, I see. it is. That's a good question. I can't immediately. I haven't heard about it.
Let me check where. I don't remember where I saw it.
Yeah.
So basically, what I'm thinking is, by the choice of using which an RS value, we might be able to indicate which public key we're using. It's a little bit quirky and probably not good either. Yeah. But besides, how does the verifier know which value I'm using? Because when I decide to use RNS, there's no indicator which one is the first, which one is the second either. So yeah. Okay, so basically we have three three things. One is we extend the sequence into RSV, and by extending the sequence, that means the signature will be different from the in-memory representation of the attestation. And second is, since it's going to be different anyway, why don't we use R equal to something, S equal to something, and V equal to something? And lastly, we can use some different separator character to indicate which public key to choose. Okay, anyway, can I proceed on? Because it seems like we just only have a handful of not very perfect solutions.
Yes.
Okay, so so the next one is encoding action. So I wish to solve this by design. Like, is it possible that we don't encode actions? We can encode action. I presented the example where the word buy, B-U-Y, is encoded in URL. But really, I want to program the actions into the attestation. So the idea is, if you want me to buy something, with the current URL, you show that you own a token because you just sent me the attestation, which is the token. Okay, let me step back. So let's say Alice is sending this link to Bob. The link that is in the encoding the action section. The link has 3 lines. Are we looking at the same link?
Yes.
Okay.
When we buy question mark.
Yes. So one way to design it is Alice sends this her attestation that she owns the ticket, and sends this thing with a buy action. So the buy action in TokenScript will be activated, asking Bob to sign something like he's ready to buy it, and then Bob can take this Bob can sign something, can offer to buy it by placing the cost, the amount he's willing to pay, and then send something back to Alice, and then Alice is able to include that in the smart contract transaction. Or maybe it should be done the other way around, where Alice will simply send attestation to Bob to show that he has this ticket, and then Bob is going to purchase it, and he will refer to this attestation in his own signed message. For example, tickets to buy value equals to the hash of the attestation Alice sent to Bob. And then Alice can send this to Bob. Bob can send this to Alice. So basically, when Bob send this offer to buy, he's already intending to buy. So maybe there is no need to include action, because basically the object class signed by Bob will be intended to purchase or bid, and that already showed what is the intention. So there's no need to encode action into the URL. Yeah, so basically, I'm along the line of thinking of not encoding the action to the attestation. I think this makes less sense if unless we put it into business context. I just hope that there isn't the business context to suddenly show up and say, hey, we actually need the actions that can be done with this token pre-selected in the URL. Yeah, yeah. Yeah, basically that's it. So I'm not sure if I should encode the action into the URL or should encode the action into the message. Well, the third thing is with an attestation that is more complicated than just the key value pair, the relative distinguished name is used instead. So if you look at section 3, you can see there is a academic transcript, right?
Yes.
Okay, so that's good. When encoding this, the entire attestation, sorry, the entire object class is encoded in the URL. Look at the URL and start. And can you see the part start with start with RPZ? After the first slash, after the smart contract address.
Yes.
Oh, RPZ YT. So that's the base 64 encoded attestation itself, which is the entire attestation. Then followed by question mark year equals to 2020, which is the relative distinguished name of that attestation. So relatively distinguished name is a set, one or several key value pair selected from the attestation to represent it, like a name. So this attestation has a name year equals to 2020. So this demonstrates that in the case where the attestation is more complicated than key value pair, then the attestation itself is encoded in base 64, followed by question mark, followed by the name of that attestation, followed by signature. Yeah, basically that's it. So I have nothing more to say. This is so far what I have.
What if the result is for one semester instead of for the entire year?
Oh, that object class might define the name of the object being year equal to something, semester equal to something. So I will type this. So a relatively distinguished name, RDN. RDN is in the format of key equals to value, comma, key equals to value. See the message I typed?
Yes, okay.
So every object class defines the makeup of its own RDN. For example, one RDN is organization equals to Alpha wallet. Okay, that's the RDN of our company's attestation, and the personal one is different. For me, my attestation of my identity is common name equal to Wei Wuzhang, followed by ID equal to something. Because unlike companies, common people can have there might be two people named having the same name. Therefore, the RDN it has two key value pairs, not one. and it's
Okay.
specified in the schema. Yeah, I guess that's it.
So I guess the big open question is still the best way of coding the selector value v, right?
Selector value, yeah. So that's on
I was just recapping the whole meeting up the last segment. Yeah.
So the big problem is how to encode the value v, which is a selector. And Vitalik coded value v because it's RSV, but actually I think he likes his name. Like there are multiple ways to do that, and every way is ugly, but yeah. Yeah. Okay. So that's the only problem. And we cannot avoid it. We cannot not encode the way to represent a public key, because otherwise, actually we can. Okay, actually we can. Here is the deal. Boon, I have this I have this idea. Do you think it will work? So we simply don't encode it. You know, the public key is part of the attestation in memory representation, right?
Yeah.
Therefore, the parser can simply try every public key and see which validates the signature.
Yeah, assuming assuming there's a limited amount of of public keys, but I guess we only have 2 in this so far, right?
I guess I linked an article which says there are only 2, but I cannot verify if the article is correct. You know,
Right.
the first sentence, there are 2 public keys recoverable.
Yeah. Okay. Yeah.
There could be more than 2. I don't know, but if there's only 2 or 4, that should be all right. We just go through every one of them. If none of them validates, we simply say the attestation, the URL is invalid. If one of them does, then we know which public key it is.
Yeah.
Do you think that would work?
I think so.
Oh, okay. So problem solved.
I don't. There shouldn't be a big issue with this. I mean, the only.
And you know what? You know, Vitalik has to do value v, because in Vitalik's schema, everything that is being signed, the signed message itself does not contain the public key. Well, if you use X509 or our attestation schema, because the signed message contains the public key, it's possible to figure out which public key is the right one.
Yeah.
Yeah, okay. So if I come back and confirm that, okay, this is the right way to go, then we're done. Today we achieved everything.
All right, cool.
Okay. So yeah, just have a look at the 2 public key article if it's correct, and I'll have to hang up unless you can. I'll give you the answer in 2 minutes.
No, I'll get back to
you. Okay. Yeah. Okay. Great. Then get back to me later. So thank you, everyone. I hope you enjoyed the meeting.
Yes. Thank you.
Okay. Thank you. Yeah. Bye.
Thanks. Bye.
Bye.